Hey folks, welcome out there. We are so excited you have tuned in to watch us. I am here, you are here. It's Mathline time. Ernie Roberts here with you today, and we want to thank you for tuning in. I am your host for this afternoon's session. We hope you're ready. We hope you're gung-ho. We hope you're ready to call. Yes, that number, 844-686-2378. Love it when you call us. We love it when we can work problems out together live on the air. And that's what our whole point is. We've got operator waiting too. Once again, that number, 844-686-2378. And to get you primed up a little bit here, let's take a look at our problem of the day. Problem of the day today, a little different switch up here. It says, how many lines can any 4 points, A, B, C, and D, determine? And in parentheses, we've got there will be more than one answer. So, folks, that kind of based on what's the arrangement of these points. And also, the word line. The word line means just that, okay? So let's take a look at this thing and see what we're going to do with it. And as it says, how many lines? There we are. Key word. I noticed on our Facebook friends, many of you were linking them as line segments. Segments are different than lines. Remember, lines have the arrows that just keep going. And most of you got this point, all right? And once again, I'm going to give a shout out to Chip, David, Margie, and Vicki for responding in many different ways on this one today. But let's just put 4 points down here, any 4. No rhyme or reason. There they are, 4 points. We'll label them A, B, C, D. Now remember what I said a little bit earlier. The answer to this question is going to depend on where do we put these points? How do we work them together, all right? So I hope you're looking at it right now and you're thinking, oh man, it looks like a little quadrilateral could be done. So let's do so. We'll draw a line through points B, C. And notice what I'm saying, lines keep going. Don't stop them. Line segments have the endpoints right there. These keep going, all right? Let's do another one. How about it? A to B. Looks good. Line it out. And how about A to D? Get the idea. Everybody's doing well. Okay. And I got that C to D. And again, the key word is lines. Don't stop them and don't make a quadrilateral. You're going to make a lot of lines, okay? And a quadrilateral just happens to form in the middle of it. Now, what's missing here? We're not done with this one yet, are we? We're going to draw a line. Oh yeah, 2 points determine a line. So there's another line. All right, right there. It's number 5. And here we go with number 6. Woo, I've drawn 6 lines. So the answer to this part is 6, okay? This is where you get 6 lines. Now, I had a couple of people who were our Facebook mention. I mentioned those names here. Give a little shout out to them. They were also asking, well, does this mean we can look at it 3-dimensionally? Because this is pretty much flat. It's just 4 points on a flat page, you know, and you got a quadrilateral. Would there be a different answer if we arranged them in 3-dimensional? Well, let's say we have 3 down here. See if I can do this. Right here, my 1, 2, 3 points. And 1 up here, I'm still going to have the same amount of lines because I'm connecting 2 points at a time. And I'm going up, up, up. So there's still 6. So that doesn't affect the answer to this part of the problem. What affects it is, how do I arrange these 4 points, all right, on the flat surface? We're going to keep it flat surface, all right? So think about this, those of you tuned in today, right now, watching, going like, wow, what's he going to do? How are we going to do that? Well, here's the first thing I'm going to ask us to do. Let's put down 3 of these points, lining them up. In a straight line. Because you see, once I pick up, let's call it A, B, C right here. Once I pick up A, B, and C in one line, I picked them up in all. So in terms of different distinct lines, my friends, we got the same line coming for A and B. We've also got the same line coming for B and C. Whoa. And also, how about A and C? So there we have a little bit of a difference, but here's the catch. What about D? Don't put it on the line. Put it somewhere out here. Doesn't really matter. Put a D right up there. Everybody watching with me? And let's connect these little guys, all right? Now we're getting our second possible answer here. All right, we had 6. That's what Facebook gave us quite a bit of. They didn't quite catch these parts here. I think that, once again, it was all about the words lines versus line segment. There it goes. We'll move that point a little bit. There's number 2. Well, actually, number 3. Actually, we've got a triangle, don't we? Let's draw one more in here. How about it from D to B? And oh my goodness, there is the 4th line. So there we have 4 lines working for us. This one, and we've dropped down that lower third. We'll keep that answer with us there, all right? There we go, 4 lines. And now let's get one more situation. Let's line them all up, because they could happen to do that. And guess what happens? If they all line up, how many lines are we going to get? We are going to have 1 line left. Absolutely, 1 line, because they're all, it doesn't matter which 2 points, 3 points, 4 points on this, they're all going to name the same set of outcomes. So here we go, 1 line left for here. So you could have 3. Nope, you never could have 3, could you? You had 6. Some of you were thinking, did he have 3? No. 4 and 1. There is your situation. There are more than one answer to that. And how about it? Those are your 3. There are 3 answers. All right, okay. And folks, that's a little bit of thinking outside the box. But when we talk about placement here, see, we just said any 4 points. We did not restrict where they were. So it wasn't a trick question, just to let you think, all right? And speaking of letting us think, we've got a caller waiting on the line today. And welcome to Mathline. Who am I talking with?
Alyssa.
Alyssa, it's good to have you back again. How are you today?
Good.
Good. And can you refresh our memory and mine too? Where are you calling from? What city or what county?
Spencer.
All right. Is it Fentress? Is that right?
Spencer.
Spencer. Okay. All right. Gotcha. So we're glad to have you with us this afternoon. What kind of problem have you got for me today?
A division problem.
All right. What are we going to be dividing with here?
3. 3 divided by 636.
3, and I bet, did you say 636?
Yeah.
All right, so we're going to take 636. I'm going to ask you, does it look like this? Is it written like that?
It hasn't set up on my TV yet.
Oh, okay. I'm going to give you 2 looks here. Does it look like, when you get to it there, does it look like this problem, or does it look like this problem?
It looks like the doghouse.
So you're talking about with the 3 on the outside and the 636 on the inside, right?
Yeah.
Okay, all right. So I want to make sure we got that straight. So keep that in mind when we say 3 first here, we're going to say not divided by. I'm not trying to be picky about it, but we want to make sure we're saying divided into, all right? What's actually happening, you're saying 636 divided by 3. You understand what I'm saying there, Alyssa?
Yeah.
Okay. Just want to make sure I want to make sure we have the problem right, okay? Because it is a different game if they switch places, obviously. So let's do it here. Let's take 3 and we'll divide that into 636. Are we good?
Yeah.
All right. I got a little space. You got a little space. You didn't give me any decimals this time. Thank you. For those of you who missed it on there, Alyssa and I had a little, not the decimal problem, but we had a little multiplication moment there. So, but we're going to be good today on this, and I think we've got this one under control. So let's see. First of all, no decimals this time, right? You didn't have any decimals for me to do. It looks like I put a point right there, and that's okay because it's just division. So don't worry about that, folks. There we go. But this one here is where we are. So let's divide 3 into 6. How many times you got for me there? How many times will it go in there? Yeah, go 2 times, right? And so let's go 2 times, and I'd like to put that little times there because that reminds me we've got to multiply. So we say 2 times 3, which is going to give us 6 right there. And Alyssa, we don't have anything left over, do we? We don't have anything left over after we subtract 6 minus 6, do we?
No.
So we're going to bring down this next digit, which is a 3, and we're going to play with it a little bit. 3 into 3, I bet you can tell me that one also pretty easily. How many times will that go in there? 3 divide into 3. So 1 time? I think we're getting a little distant connection here. And I'll put a 1 right there for you. Are we good?
Yeah.
All right, there you are. Good. If you'll just talk with me, we'll be good. 1 times 3, that gives me 3. And again, I lost everything. It's gone, isn't it? except
Yep.
for my last digit, my 6 has to come down.
Yep.
And we can get back to 3 going into 6. We've done it once. It's still the same, isn't it? So
Yeah.
we'll put a 2 up there. And I believe that's going to give us a nice, oh, we don't have a remainder this time. Isn't that always nice? It's always nice. Now, Alyssa, I'm going to do one thing with you because I find that it helps us if we check it back through. And if we take our 212 and we multiply by our 3, we should get 636. So are you with me on that?
Yeah.
In other words, we're going to reverse the process and check. So 2 times 3 gives me 6. We're good. 1 times 3 gives me 3. And I got 2 times 3, which is going to crank back over to 6. And that matches, a little more arrow there. Those two match together, what we started with and where we ended up. Good to go. All right. How does that work for you?
Good.
Are you excited about the weekend coming up soon?
Yeah.
I am too. I always enjoy those weekends. So you have a good afternoon. And Alyssa, thanks again for calling us, all right? And we look forward to hearing from you next week.
Okay.
All right now. Bye-bye. And folks, that's how easy it is. Alyssa's shown you what to do. Give us a call, 844-686-2378. We'll take your arithmetic questions. We will take your algebra, your good old pre-calculus, geometry, all those good things, even some statistics if you'd like. But give us a call, all right? We are here, and pre-algebra stuff is also welcome, these kind of things. So we're playing today with, looks like, some of our numbers, and also we did a little mind games there with arranging things in a geometry type pattern, the problem of the day. So again, sky's the limit today. It's Thursday. Give us a call, all right? And while we're doing that, let's check a problem here that I thought was very interesting. It says compare the results of, and we've got one picture here where we've got a 6 and we've got a 6 here, but we've got a mixed number in decimal form here. We've got a mixed number in fraction form. We're going to compare the results. In other words, will we get the same, or are we going to get something different, or what are they going to look like, all right? So some of you are going like, I catch on to this already. I see what's going to happen. And some of you are going like, I wonder where he's going on this. So let's do first thing. Let's take our 6 and let's subtract this 2. And how about it? 375. Now, if I'm going to, I don't know why I put that thing there. If we're going to subtract, I think I was going to put a subtract there and rewrite the problem. But while you're doing it at home, go ahead and do that. And some of you are saying, well, Ernie, we need some places, don't we? We certainly do. So I'm going to fill in that little blank with a few zeros. We can throw those in there. That is a great way to do this, all right? It's a great way to take this problem because we are allowed to add zeros without changing the value of 6. 6.0, 6.00, all those still equal to the same amount, all right? So what we're going to do, we're going to look back and say, oh my goodness, we can't subtract anything across through here. So we've got to go all the way over to the 6. Alyssa would be helping me on this, I'm sure, if she were still with us here. And we have a 5 right there. But what we're going to do, we're going to rename. We have lost some stuff, but we've got to put it over here. We've got to fix it. So now we don't have a 0 anymore. We have a 10, which gets kind of messy, doesn't it? And especially when I'm writing through slashing. And we're still kind of stuck because we can say 10 minus 3, but we still have a 0 minus 7 here. So let's go work a little more. Pull that 9. And once again, bring a 10 over here. In other words, we're going to split now tenths into hundredths. So we're taking 1/10 and we're making 10 hundredths out of it. Woo, that makes it crazy, doesn't it? So I'm going to say goodbye to that and put a 10 up above there so we can see what's going on. And we're good to go. 10 minus 7. Unfortunately, we're not good to go on the end yet. So let's go one more time. Take 1 out of this. Now we're taking 100th and making into 10 thousandths. So let's make that go to 10. And finally, we can do a subtraction here. So we're going to take 10 minus 5. We'll get a 5. That looks great. We've got a 9 minus 7, which we like that because we can do that. 2. 9 minus 3, how about it? We get 6. And over here we've got 3. So our final value here is 6. And I'm sorry, not 6. It's what? 3 and, we'll say it right, 625 thousandths. Wow. Question is, what are we going to get here? So let's do it. I like to do a vertical fashion on this. We're going to subtract 2 3/8 from our 6. And once again, we have nothing out there to subtract 3/8 from. So let's pick up and put 0 over 8. No, you say, Ernie, why'd you do that? Well, I'm just saying 6 plus 0. It just tells me I have nothing, but I have it in eighths form, all right? That's what I want. That's what I want. Now, let's see something here a little bit different. We're going to do the same thing. We're going to regroup. We're going to borrow from the 6 and make this become a 5. Already some of you are saying, 5 minus 2, we're going to get a 3. Absolutely, you're looking ahead. The question is, what are we going to pop up here with the 0? We're not going to put 10 this time, all right? I want you to notice, here we started with tenths because we're talking tenths, hundredths, thousandths. Here we're talking about, eighths, the digit 8. So let's put a plus 8 over here because that's what we're doing. We're adding 1 to this amount, which is 8 over 8. Let's do it. You get a 3, you get a 5, you get 3 and 5/8. Question is, are those the same? Oh, are they the same? Yes, they are. Back here, these were the same. 3/8 is the same thing as that decimal. But let's see, could we get back to 5/8 here? 5/8 is the easy one to go to. This one's a little bit tougher to go from 5/8 over to that one. Let's do this. Hey, you say, Ernie, you can divide 8 into 5? Yeah. But let's do what we got here. Let's put it over 1,000 because it's thousandths. And let's see what we can pull out of this proverbial thing here. I think we can divide by 5. We'll divide both these by 5, which is going to break us down to, I'm going to pull it down here, 125 out of 200. Looking better. Let's divide by 5 again. I see, Ernie, why are you doing 5s? Because we have 5s and 0s on the end, so we know 5 will divide in there. Now we're down to what? 25. Wow. All of a sudden looking a lot better. And I believe that's going to give us 40. Think of that. And by the way, some of you wonder, how do we get to 25? Think about your money. $1.25 divided by 5. That's pretty good, isn't it? And last but not least, my goodness, it's another 5 going our way here. Let's divide by 5. And my goodness, look what we have. We have 5/8, which brings us right back to there. And of course, the 3's matched. So that's our story on that one. Those are actually equivalent fractions. They represent the same thing. This is what we call a decimal fraction. That's what we just call a good old fraction based on 2 integers. All right. So good point there. And understand, I have another caller waiting for me on the line. So welcome to Mathline this Thursday afternoon. Who am I talking with?
Crystal.
Is Celie, is that correct?
Yeah.
All right. And where are you calling from? What city or what county? We're getting a little bit of feedback. If you can mute your TV for me a little bit, okay?
Huh?
We're getting a little bit of feedback. If you can mute your TV down just a little bit.
I'm watching you.
I know, but I appreciate that. If you'll turn it down just a little bit, because I'm hearing a little bit of feedback from it. And just listen to me on the phone, and we'll be good, and you can watch me on the TV. How's that? And everyone else will hear you too. So, what's your problem for me this afternoon?
I need help with my decimals.
Okay. Can you give me a situation? What kind of problem are we going to look at? Add, subtract, multiply, or divide?
Divide.
All right, let's do a division here. Let me flip a paper over here. We're good. Can you give me your problem for me?
It's 25 decimal 8 divided by 12.
25 and looks like 8/10, and we're going to be dividing that by 12. So the 12 is going to be on the outside when we work through this, correct?
Yes.
All right. So I'm thinking, and folks, once again, as we read this piece right here, it is 25 and 8/10, or 0.8, divided by 12. When we write that, we want to make sure that we're putting the 12 to the outside and the 25 and 5/8 as we work some good old long division here today. My goodness, we're doing a lot of division, aren't we, on this show today? So we'll, first of all, let's take a look at an estimate here, because I get kind of antsy when I see double digits, don't you? That's what, it's easy when there's one digit out there, but when you got 2 of them, you got to start thinking, how do I get started? And what I would do on this one, 12 is not too intimidating, but I would look at the 1 and the 2, get a little estimation. Estimation is such a wonderful thing. It gives us a starting point, and we hope it'll be pretty close. So I'm thinking about 1 will go into 1 will go into 2 times, won't it?
Yeah.
So let's try that 12 times 2. I think we probably can figure that one out. Just double the 12. And we're at what? 24. Are we good on that? So we're going to put that 24 right there, and we're going to subtract. But what are we going to put up above it? Right above the 5, we're going to put the 2. Now, do you see why I put it above the 5?
Yeah.
Because I can't say 12, it goes into 2. I have to say what? 12 goes into what? 25. So the 2 is going to go directly above. And that's important because that's going to tell me where this decimal is going to land. You see? Because we're going to send that decimal straight up before too long. All right?
Okay.
Now, bring down the 8 because we still got to play with it, don't we? This one looks fairly straightforward, doesn't it? This time you've got 12 into 18. It's going to go one time, right?
Yeah.
So we'll put a 1 right there. And again, remember, we're going to say 1 times 12. 1 times 12 obviously is 12. And then, here we go. Salih, we have a 6. Now, since you've got a decimal to start with, I'm going to go out on a limb here and say we need to add a 0. And we can do that. And hopefully this thing will end. It will have a final resting place. Okay, you see what I just did?
Yeah.
Because it's kind of like if you had $25.80, it's just the same thing. And sometimes now in restaurants we see 25.8 as the price. Okay, it still means there's 80 cents there. Okay, so we just added the 0. We didn't change anything. We just tossed the 0 in. And we're going to bring that 0 straight down because now we got 60. So we're going to have to think a little bit, but I noticed that if we know our 12s, I know that's 24. If I go to times 4, I'm up to 48. Whew, I'm getting close to 60, aren't I? Let's try 12 times 5. See what we get. And Salih, I think we're going to have 10. Carry my 1. I'm getting 60. Does that look right to you?
Yeah.
So we're going to put that 5 right there, and we're going to end up with 60, and we have nothing left to go with, which is great. That means our problem is done. Now, the question is, probably in your case, since you said you're struggling a little bit with the decimals, where do we put the decimal? We take it straight up. You see it?
Yeah.
And we've got 2 and 1500ths times 12, which should give us 25 and 8/10. Would we like to do it on the calculator just to check the multiplication? Not going to do the division part, but I want to check the multiplication because that's how we do it. We take the 2 and 1500ths and we will multiply that thing times 12, which is what we were working with, right, Salih? And there you have it. There's your 25 and 8/10 that came back out. So easy check. And let me go back to the real paper here. That would be, folks, basically taking what our response is, our quotient, as we like to call it, times 12, and we do come up with 25, and we can put that extra 80 on there. We understand that is still the same thing as 8/10. Okay? Does that work for you? Does that help?
Yeah.
All right. Well, thank you for calling in this afternoon, and thank you for watching us today and getting to watch while you did the problem. Did a great job with it there, and thank you for being a part of our show. And give us a call back when you need to again, okay?
Okay.
All right. Thank you. And folks, that's how it works there. Woo! Almost to the end of the show here on a Thursday afternoon. Any other callers, we'll be glad to take care of you and listen to you. But while we're waiting for a couple of more calls, let's see. Can we take a look at how we do Facebook around here, all right? Because I mentioned Facebook with some of our adults. I know young folks, you think that's the old folks' place to go. I know. But you also can catch us on Twitter and Instagram and all those other good things too. So be looking for us there. www.facebook.com/Mathline Online. That's where you can get those problems of the day. Now we're getting them up a day in advance. So all you folks who like to get in there and see those problems in advance, that's the place to do it, all right? Go to Facebook, like us, love us, and above all, share us because we want people to know about Mathline. We also want to get up to, we're shooting for that 1,000 likes by the end of the, wow, how about it? By the end of the month? Could we do that? Hope we can. If you haven't liked, a lot of you come in and like our pages, per se. That's why we do the whole page. But some of you just like the problem, and that's great. But we want you to also like our site too. So be sure to catch us on that. Another thing, we've got YouTube, where you can see our Friday shows when we get them up there and in their entirety. And also you can see our problem of the day played back for you in case you missed it. So subscribe to www.youtube.com, we'll get it there, /Mathline. And that is one other way that you have that you can check us out, especially if you miss one of our shows. Hey, there it is. And also understand we are streaming, maybe streaming today. So that's why we had some folks from the Philippines and Ethiopia that have picked us up and sent us questions occasionally. So you join the group, all right? Join us all. We have email also. But tomorrow, specialized segments. Trig, we're going to be looking at sin, costan, sine, cosine, and tangent again for you tomorrow. Practicing with those. So those of you who are taking some geometry right now or you're taking a pre-calculus, it's a good right triangle review for your trigonometric ratios and functions. So be sure to check us out on that. And of course, back next week, we'll be live 4 days a week next week. And you know what? It's exciting because it's almost the end of August. And you know, you all are back in school now. I'm ready to rock and roll. You keep calling us. And again, like as always, you know, we appreciate you tuning in today, and we will look for you next time.